At first, I want to apologize because my presentation is not very informative because I just arrived in Lebanon and a few days later I'm here in Paris. So I was busy with making contracts, opening bank accounts and all these things. And I should thank Lucas because I used his presentation to make mine.
Okay.
I'm Soheil Samadi from Mountain University of Lebanon. My supervisors are Dr. Jean, Dr. Gruber, and Professor Harmus. My project thesis title is Thermomechanical Modeling of Industrial Lines. At first, I will introduce myself and I will talk about my background, and then I will shortly explain my current project. I'm 25 years old, and I'm from Iran, as you know, very deep.
So much Iranian.
So much Iranian. They call us Iranian Mafia. My big ambition is to become a successful industrial researcher, and I think ATHOR can help me very much in this way. My favorite activities is also hiking, swimming, watching and playing football, and my favorite team is Barcelona. That is my university in Iran, University of Tehran. My background, I studied at University of Tehran, the oldest university in my country, for my bachelor degree in mechanical engineering. In that time, I was teaching assistant in 2 courses. And I also found out that I'm interested in working with different pieces of software in engineering. So I learned about MATLAB, SolidWorks, and C++, and I used them in different courses and my thesis. Then I got accepted in Sharif University of Technology for my master's degree. That is the best university in my country in engineering. And I also continued in mechanical engineering because I always was interested in the fields like mechanical engineering that have a real problem in industries, and the software that I learned in the master's degree was Abacus and MATLAB. At the last year of my bachelor, I got accepted for a traineeship in a big company in my country, Tehran Javan Consulting Engineers and Managers Company. This is a company that performs some projects, especially in the area of gas and oil extractions. My job was there to model some of their facilities that they use for their projects, and also do lots of analysis with Abacus, for example, fatigue analysis, creep analysis, and other things. For my master thesis, I developed a novel stability-based CMG-assisted optimization model of the spine. It was around 2,200 lines of code in MATLAB. My challenges was applying stability conditions for human body for the first time. And also I had to investigate nonlinear behavior of invertebral discs. And also at the end I had to validate my model with the experimental results. And I also published a paper in Journal of Medical Engineering and Physics. This experience learned me that I'm not really interested in human bodies, so I instantly changed my because I got in love with industries and industrial problems from my work experience, so I chose to come to ATHOR and apply for ATHOR. And I want to explain my current project now. I have to develop a model for simulation of industrial mining. I should come up with a model for that, and my project has 2 main parts. At first, high temperature mechanical properties test, and then FE simulation. For the first part, high temperature mechanical properties test that we will do in the university. At first, there is IET measurements that it would be in high temperature and also room temperature. Then we will do some modified shear tests for investigation of shear failure of the refractories. Also wedge splitting test for investigation of tensile failure of refractories. And also Kirk tests. We have two equipment, high temperature compression Kirk test setup and tensile Kirk setup. That part will take about 1.5 half year of my project. Along with that, I will start with FE simulation. At first, I will set up FE models using Fortran and Abacus. And then we will implement and also evaluate different material models for tensile failure, shear failure, and also creep. And we will evaluate them with laboratory files. And after that, we will evaluate the thermomechanical behavior of linings in different lining zones of a steel ladle. And at the end, the model that I will develop will be compared with other approaches, especially with the approach of ESR10. Thank you so much.